What if the entire universe is not just made of energy and matter, but of information? What if reality itself could be computed, one quantum state at a time? Welcome to the Learning Studio, and in today's episode from our physics playlist, we'll step into one of the most revolutionary ideas of our time, quantum information and quantum computing. You can explore the complete physics playlist by clicking the link in the description below. This topic is part of our section Quantum and Relativistic Revolution, where physics meets computation, where we explore how the universe's most mysterious laws are shaping the future of technology and intelligence. From bits to qubits, a new kind of information. Every computer you've ever used, from your smartphone to the world's most powerful supercomputer, runs on classical bits, zeros and ones. Every image, video, and word is ultimately reduced to that binary foundation. But the quantum world doesn't play by such simple rules. In quantum physics, particles don't just exist as this or that, they can exist in superpositions, meaning they can be in multiple states at once. And that's where the qubit, or quantum bit, comes in. Unlike a classical bit that's either 0 or 1, a qubit can be both 0 and 1 simultaneously, until measured. This property allows quantum computers to perform many calculations in parallel, unlocking a level of computational power that classical systems can't even begin to reach. But that's not all. When qubits become entangled, their states are linked, no matter how far apart they are. Change one, and the other responds instantly. It's as if nature itself is computing across the entire universe. Quantum algorithms, harnessing the impossible. Quantum computers don't just run faster, they think differently. Instead of following a linear path, quantum algorithms explore all possible paths at once. One of the most famous examples is Shor's algorithm, which can factor massive numbers exponentially faster than classical algorithms, posing both challenges and opportunities for cybersecurity. Then there's Grover's algorithm, which can search massive databases with astonishing speed. But the real breakthrough is happening where quantum computing meets artificial intelligence. Quantum machine learning, the future of AI. Imagine AI systems that don't just process data, but understand probability and uncertainty at the quantum level. That's the promise of quantum machine learning, QML, where quantum processors accelerate pattern recognition, optimization, and generative modeling. Quantum computers can analyze complex energy landscapes, simulate molecular structures, and optimize neural networks in ways classical systems can only approximate. For instance, quantum-inspired models are already helping physicists and engineers design better materials, predict chemical reactions, and train faster AI models. And as QML advances, it could redefine how we train algorithms, not with static data, but with quantum patterns that evolve like nature itself. The physics behind the code. At its core, quantum computing is pure physics, built from superposition, entanglement, and interference. It's not just a new way to compute, it's a new way to think about reality. Every quantum gate, every circuit, is a carefully choreographed dance of particles and probabilities. Even the simplest operation, flipping a qubit, requires manipulating the fragile balance between quantum states. That's why building a quantum computer isn't just a computer science challenge, it's a physics masterpiece. It demands mastery of cryogenics, laser control, electromagnetic precision, and quantum error correction, keeping delicate qubits stable long enough to perform meaningful computation. A quantum future. We are standing at the edge of a technological revolution. Quantum computers are still in their early stages, but even today, they are solving problems that would take classical supercomputers centuries. In the coming decade, quantum computing could reshape everything. From cryptography and finance, to climate modeling, drug discovery, and AI architecture itself. It's the next leap after the digital revolution, not just faster, but fundamentally different in how it processes and understands information. Quantum computing reminds us that the universe itself may be the ultimate computer, one that computes reality through the language of physics. This is the Learning Studio, and this was our episode on quantum information and quantum computing. If you enjoyed exploring this glimpse into the next era of science and technology, don't forget to subscribe, like, and check out our physics playlist linked below. In our next video, we'll explore the mysterious world of quantum entanglement and information theory, where communication defies distance, and reality itself begins to look like a web of shared information. Because in the quantum world, everything is connected, not by wires, but by possibility.